Alrighty, Math 20-3. So we are now on to 2.2 bar graphs. So on 2.1, we talked about this, we talked about, let's see here, I'm having a brain fart. We talked about broken line graphs, okay? So with broken line graphs, that's where you have something that's like this, and you have points in between, okay? Kind of all throughout, and then you connect those points using a broken line, okay? Now, the thing about broken line graphs is, remember, you can have points in between these. So you could guess what a point was there. Now, this only works for types of data where you can have like fractions or decimals. So like time, you can have a portion of time, right? Like if this is 1 hour and this is 2 hours, you could have technically 1.5 hours, okay? How do we deal with data, okay? How do we deal with data that you can't have in between values, okay? This is called discrete data. So discrete data made up of distinct values where intermediate values are not possible, okay? So that's kind of a bunch of jargon there. For essentially, you can't have a portion of whatever you're talking about. So for example, it would be like the number of students, okay? You cannot have 1.5 students, okay? Even if somebody's missing their legs or missing their arms, they're still counted as a student. They're not half a person, okay? So that's what discrete data is. When you're dealing with discrete data, you want to use bar graphs. So we can kind of highlight what these look like. And bar graph shows the number of something. So if this is like 3, 2, 1, and here we would be dealing with maybe like orange. Maybe we're talking about cars, how many cars we have, blue and green. Okay, so we have 3 green cars. We have roughly, this should actually go up to 2 as well, 2 blue cars and 2 orange cars. Okay, you couldn't have 1.5 of a car. Okay, so that's what bar graphs are really used for. They're used for discrete data. So again, discrete data being something that cannot be like halved or cut in half or a third. It has to be a whole number. Okay, so let's go and look at a few examples here. So here, remember what we have to do when we title graphs. So it's the same as 2.1. You need a title for the entire graph. You need to tell what your value is on your x-axis, which is also, again, reminder, your independent variable. In your y-axis, you need a title and tell what that thing is. Okay, and remember, this is the dependent variable, which is your title. And then you would have to list what each bar represents. Okay, so each bar gets its own title. So it's like here, a company tracked how new software was obtained. So a company tracked how new software was obtained and installed on their computers. The results are given in the table below. Draw a bar graph to represent the data. Okay, so we have a bunch of things here. I'm gonna give the title first off. Okay, so let's read the sentence again. A company tracked how new software was obtained and installed on their computers. The results are given in the table below. Draw a bar graph to represent the data. So this is percentage of total software installations. So businesses with percent of software. I just spelled software way wrong. Wow, that was bad. Software installations. Okay, so there's a title. Sometimes the titles are a little hard to come up with, but don't overthink it. Okay, I'm gonna decrease this a little bit. Now, we have a bunch of different providers. Okay, so we're gonna list those providers. Okay, those are gonna be on our x-axis. You can do it kind of both ways. So you can see down here, that this is actually called a vertical bar graph. Whichever one works for you. I'm going to do it a horizontal line graph. So I'm going to list every single thing here. So I'm actually going to give these things little nicknames. So this is going to be called in-house IT department. What I'm going to do is I'm going to make it INTD, okay? In-house IT department. This one I'm going to put in-house provider, so P instead of D. This one I'm going to make OSP, so outsourced to service provider is going to be OSP. Outside to development provider, this is going to be ODP, and then this is just going to be other. Okay, because writing these names would be super annoying. It would take up a lot of space. So now when I do this, it'll just be INTD, okay, INP, OSP, ODP, and other. So as long as you show me that you do this, it's okay. It's called a legend. We're essentially making a legend there. Now, what's the biggest number you're going to be dealing with? 58. The smallest numbers you're going to be dealing with 40. So I'm going to go up to 60. Okay, and what I'm going to do is I'm going to go up by tens. 10, 20, 30, 40, 50. Okay? And now at this point, we can start drawing our bars. Okay? One thing I forgot to do is title these guys. So I have my title for the whole graph, but what's this side thing? Okay? Well, this side is percentage of total software installations. What's this on the bottom? This bottom is how software was obtained and installed. So this is just software providers. Okay, so we have our titles now. Okay, now we can start making our bars. So in-house TD department, so I'm looking right up here. In-house TD department, which is INTD, they had 58%. So I'm going to go up to 58%. 58% will be roughly here. And you would not make that slant. You would try and make that as straight as possible. Okay. INDP, which is here, that had 16. So 16 is roughly right here. Okay. OSP, which is outsourced to service provider, that had 10. So a little bit smaller. Outsourced to development partner has 12. So a little bit larger and pretty much like right between OSP and INP, right? And then other is 4, so that's the smallest. So pretty much not breaking it. Some things to note, okay? You want each bar to be roughly the same size. So bars, roughly same width. Okay, obviously not this way, tall lengthwise, okay, because they're all going to be different lengths, but how fat they are kind of thing is what's important. So this way. They should all roughly be the same because at the end of the day, that way doesn't mean anything to us. So there's our bars. That's our bar graph. Okay, and you could read it from there. Now let's look at number 2. So number 2 is a vertical bar graph. The following graph shows Jamie's height from age 10 to 18. So it looks like we have some questions on A here. So if we look at it, remember, always analyze your graph first. Okay, so we're talking about Jamie's height. There's the title. We have Jamie's height here. We have his age, and then we have his height down here. We can clearly see there's a trend where he's growing, and then he's kind of plateauing. So plateauing means he doesn't really grow any size or shrink, okay? Shrinking hopefully doesn't happen until you're really, really old, if it happens at all. That makes sense too. Once you're about 18, right? Once you're about 18 years old, you're probably reached about the height you will be for the rest of your life. Maybe you'll grow a little bit more, or if you're one of those lucky people, you'll grow even taller. If you like to be tall. Maybe you don't want to be tall. Who knows? Anyways, so suggest 2 ways to improve the way the data is represented. Okay, so how could we represent this a little bit more nicely? Well, one thing I notice is we're only really talking about the range from about, I would say, 125 centimeters to roughly 180. So why not shrink that down a bit, okay, and have a bigger scale? So I would say try and make the scale a little bigger of height. So aka, I mean, don't go up by 50. Why don't you go up by smaller increments, so like 25s? Okay, so the thing would be lengthwise a little bit longer, but you could tell the difference between these heights a little easier. Something else I notice is they put age on here. Remember that this should be the independent, sorry, not independent, this should be the dependent variable. Remember, time is always independent. We have no control over time. So I would say put time on the x-axis. Lastly, what do I notice? Can you be between 150 and 200 centimeters tall? You absolutely can. Is this really discrete data? Okay. Recall what discrete data means. Discrete data means you can't have like fractions or portions of what you're talking about. But we absolutely can. We can be 155.5 centimeters tall. We could be 100.257 centimeters tall for sure. So this should actually be shown using a scatter plot diagram, which again is found in 2.1. So we should have represented it like this using plotted points. Okay, so this should be represented using a broken line graph. Should have used broken line graph. Okay, because we can be in between these points, right? From the ages of 17, or let's make it a little easier to see, from the ages of 12 and 11, okay, we are between those heights. So we should be able to connect those points and roughly estimate that. Redraw the graph in a way that better represents the data. Okay, so again, I'm going to follow my advice here. Put time on X scale. So I'm going to put time here, and remember it's in years. So 1, 2, 3, 4, 5, 6. It's going to be a while. 6, 7, 8, 9. I'm only going to go up to 9, but you would want to go up all the way to 18 if you were doing this on a test. Okay. Now, we are between 0 and 200. So I'm going to keep that the same. It's not awful to have that. Okay. So actually, what I'm going to show you is something a little different. Say we don't want to start at 0. What you can do is do a little crunch. Okay, this means not starting at 0. Okay, we're not starting at 0. So I'm not going to bother with starting at 0. And I just realized our timeline, he's starting at 10. So this should be 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. I'm putting a little crunch there because we're not going to start at 0 centimeters. Okay, we're starting to collect our data when he's already 10 years old. So he's already at how much height? At roughly 125. So we're going to start at 120. Is that smart? Yeah, let's do 120 here. And then we're going to go 130, 140, 150. Okay, and remember, this is the height, and we're going to give it centimeters. Okay, now we can start plotting our points. So when he is 10 years old, he is roughly 125 centimeters. So let's plot that point. When he's 10 years old, he is roughly 125 centimeters. How about when he is 11 years old? 11 years old, he grew to probably around 130 centimeters. Okay. 12 years old, he's about 145 centimeters. Or sorry, 135 centimeters. Okay. 13 years old, he's almost 150, so I'd say he's about 45 centimeters or 140 centimeters. So when he's 13. How about when he's 14? When he's 14, he is 150 centimeters. So 150 centimeters. See, I even messed up a little bit. I should have extended this one more all the way to 200. Okay. So, but you can kind of see what I'm doing here. Now, this is why it's important to check your scaling. So I went a little too fast and I only went up to 150. I should have went up to 200. Okay. But that being said, if you check this, now we can connect these points. Because remember, what happens when he's about 11 and a half years old? Well, if he's 11 and a half years old, we can roughly estimate how tall he is. He's about 132 centimeters. You cannot do that with bar graphs. Bar graphs don't allow you to estimate between and in between your data. These do, okay? So that's how I'd better represent it. Again, did I represent this super nicely? Not quite. I should have definitely made this go up to 200, okay? But it's always good to see your teacher make a mistake because it will stick in your brain quite a bit more. So I would actually probably erase all this, okay? I wouldn't suggest you erasing all of it, but if I were to erase all this and do it all over again, I would definitely be a little bit more cautious and do something like this. Especially on an exam, guys, you want to be certain that you are doing the proper incrementations. So again, I want it to be 200. Okay, I want to get up to 200, and my lowest value again is about 125. So I'd start at 125, and then I would go up probably by 70 or 25s. So this would be 125, 150. So this would be 150, 175, 200. Okay, so you could do it that way. I would probably even extend it a little more. So sometimes it's a little bit of trial and error. So this would be 150 here, and then 175 and 200. So that's going to make your graph look a lot nicer, and you would plot those points. Okay, and you would see a general trend going roughly this way. Okay. Okay. So let's move on. So let's look at number 5 quickly together. So given the vertical bar graph below, draw a broken line graph depicting the same data. Which graph seems to be the better representation of the data? Well, if we look here, ask yourself, can I have portions of a percent? Okay, you totally can. You can get 65.5% on a test. You could get 70.25%. So does having a bar graph make sense for this? No. Okay. This is better depicted by a line graph. Okay. A broken line graph will represent this better because it is explained down here. The graph is better because it is easier to see the trend in its test results. Not only that, you can see the trend better, but you can also estimate other test marks. Okay, so what I mean by that is, say we extended this thing. Say we took a few more tests, but say we missed jotting down 7 and 8's data. Okay, and then on the 9th test, he got 100. I would assume that on the 7th test, he did a little better. On the 8th test, he did even better. And then on the 9th test, he completely aced. Okay, so you can kind of guess these two. Okay, so that's the beauty of a broken line graph. Okay, so let's look at number 6 together. So the table below shows the number of tickets sold per day until a rock concert is sold out. What is the general trend in sales over 10 days? So we can see our days here and our number of tickets here. What do you notice about this table? On day 1, they have 2,824 number of tickets. Day 2, they have 2,531 tickets. So they are decreasing in ticket number every other day. Every day that comes after the next. Okay, so if you're decreasing, that's the general trend. The general trend is the number of tickets is decreasing. Okay. Now B says Darlene used a graph tool to draw a horizontal bar graph and a broken line graph. Which graph is better representation and why? Okay. Now, as long as you give me a good explanation and you properly give reason behind your reason, I'm usually pretty nice about marking these. You could technically make an argument for these guys. Why could you do that? You could make an argument because you can't really have a fraction of the number of tickets. You can't sell 1.1 ticket. That being said, I would probably go with the broken line graph. So the broken line graph is the better choice because you can see the trend better. So we can see the trend a heck of a lot easier on this one. You can also estimate a little bit. Okay, this one's a little easier to estimate. So here, the days of sales, if we look here, and we see that so one thing I notice is they actually, whoever made this booklet messed up. This should say the number of tickets. And this should say days. Okay. So this is also kind of nice because you could estimate, like if someone were to ask you, what were the number of tickets in the middle of the day on day 4? Well, the middle of the day on day 4 was right here. So you could roughly estimate how much that was. I would probably say this is, I would say that's about 1,500 or probably 1,600 tickets. Okay, so you can roughly estimate again. The biggest reason this is the better choice is mainly because you can see the trend a lot better. Okay, but again, as long as you give a reason and the reason makes sense, I'm usually pretty nice about marking these. Okay, now let's give this one a shot. So this is going to be a double bar graph. Okay, double bar graph is when you're comparing two different things or two different categories on the same thing. So here we have the following table shows average weekly household expenses of all Canadian households. Okay, anytime you have a double bar graph or something where you have two things, you need a legend. Okay, you have to tell me visually what I'm looking at. Okay, so you have two different things you are comparing. Okay, you have lowest income households and you have all households with children. So for my all households with children, what I'm going to do is I'm going to color in, actually not color in, that'll take way too long. I am going to stripe out the bars. For my lowest income households, I'm simply just going to leave it open. Okay. This point, we don't have to rewrite this every time we draw a graph or a bar. Okay, we know exactly what it is. So here, let's start by giving our bar graph some axes. Okay. And what we're going to title this is probably just found in the sentence here. So the following table shows average weekly household expenses of all Canadian households. So we're going to put average weekly household expenses. Okay, and that's going to be my title. Now here, I'm going to put the categories down here. So this is going to be food and drink. Okay, this will be clothing. This will be heat and electricity. We got a few categories here. We're gonna have health here. We'll have transportation. Again, if you were doing this yourself, you would want to fit every single one. I'm only gonna do a few just for example for you guys. Okay, now let's look at the lowest income household first. So for food and drink, they have 104. So make sure you look for the biggest number that you're going to deal with and the smallest number you're going to deal with, because we need to know what scale we're going to do on this side. Okay. So the biggest number I see is 176. The smallest number I see is 6. So I'm going to probably go up by, let's say 20. Okay, so 20, 40, 60, 70, or that's not going up by 20, oh my goodness. So 20, 40, 60, 80, 100, 120, 140, 160, 170. Okay. So again, you might have to erase it and kind of redraw it a little bit nicer, which I'm actually going to do to show you guys good habits. Okay, so here, let's make this a little bit nicer. So again, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. So a little bit better there. Okay. Now this will be money here, and this is measured in dollars, of course. Okay, so again, we're going to focus on our lowest income household. So they spend about $104 on food and drink. So lowest income households is 104. So if we go up to 104, that's roughly about there. Now let's compare that to all households with children, which is 140. Okay, so I'm going to do a bar right beside and go to 140. Now right now, someone looking at this would think it's both lowest income households because that is a open graph or a bar. But remember, all households with children, we're going to put lines in the bar. So all households with children go up to 140, so we have to fill this one in. Okay. Now I can look at it with this legend and it's really easy to understand. Let's do clothing together. So lowest income households have $44 for clothing. So that's going to be roughly here. All households with children is 62. Now remember, we are going to fill that bar in. So up to 62. So 62 goes to about here. Let's do heat and electricity. Lowest income's 124. Okay, so 124. We go up to about 120. And then all households with children have 130. So it's just a tiny bit larger than this one. And remember, all households with children is a filled in bar. Now you would do this for the remainder of them, and I would practice doing it. And what we can do is do B. Explain the trends in the spending of the lowest income families compared to all families. So what we can see is lower income families spend less money on things. Okay, so we can always see that lowest income households spend less money than homes with children. Okay, and there is number 7 for you guys. So remember, complete the remainder of this. Okay. Again, if you were doing this on an assignment or a test, you'd obviously have to show every category, but this is just an example. Okay. If something confused you, please rewatch the video for number 7, and you can come and ask questions if something's really not making sense. Okay. Let's go down a little bit and let's look at number 9, maybe to finish off here. Because you should be able to do number 1 at this point, okay? And you kind of should be able to finish off the remainder of these questions. But let's look at number 9. So the following graph shows the high and low daily temperatures for 1 week in November in Pincher Creek, Alberta. So this one's kind of cool because you have negative values and positive values. Now we're looking at the daily temperatures in Pincher Creek, Alberta, and it's kind of sad that I see not only 2 visible ones that are in the positives, positive temperatures, which makes you kind of want to cry, but that's okay. Now recognize we have a high and a low, okay? So that's why the legend's really important. The high of the day for Sunday here is -5 degrees, and the low for that day is -20. So that's a huge difference, okay? That's a really warm day versus a very cold day, okay? So why are most of the bars going downward? Well, what I would probably guess is this must be during the winter. Must be in the winter. Because we're dealing with a lot of negative temperatures. Lots of negative temps. Okay, why is there no black bar on Saturday? So if we look at Saturday, we can see there's no black bar. Well, that's because the high of that day would be 0 degrees Celsius. Okay, we can see here that that is 0 degrees Celsius. So the high for Saturday is 0 degrees Celsius. And what is significant about Wednesday's temperature? Well, if we look at Wednesday's temperature, what do you notice? That the high and the low of that day is the exact same temperature. It looks like it's going to be -6 degrees. So the high and low temp is the exact same. Okay, What was the general trend in temperature during the week? Well, the general trend, it looks like our lows got warmer and warmer and warmer, okay? So from what I can see, the general trend is that it was getting warmer during the week. The low temperatures were getting warmer. Okay, so that's awesome. It looked like it was getting warmer, and they even got blessed on Thursday and Friday with some positive temperatures for a high, which is pretty cool. So always look at your data and extrapolate what's going on in your graph before you even read the questions. Because if you understand the graph before reading the questions you can kind of just fly through. Okay, so you have a few to try here, like this one. Petro is a trainer at the local gym. He recorded the following information about the number of people who use the equipment during the day. Graph the data on a horizontal bar graph. This should be practice. Okay, you should be able to do this. And again, if that's totally confusing, you should be rewatching a few of the videos or coming in to ask questions. Okay, you can try number 2 out. Okay, remember, look at the graph before looking at the questions. Understand the graph before understanding the questions. Okay, number 3 you can definitely do. So you just have a few to try out on your own. And other than that, again, if you're still confused, come ask questions.